Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6 for BNT 21103 Dynamic, and the experiment is energy in a spring. For procedure 1, Hooke's law, as shown in figure 4.3, fix the plummet arm and spring to the work panel. Use a S hook to hang the spring from the plummet arm. Fix the plastic guide to the bottom of the wake hanger. Move the magnetic rule behind the wake hanger so you can measure the movement of the guide at the bottom of the wake hanger as you add weights. Adjust the ruler so the guide aligns with the nearest hole number, for example 150 mm. This is your zero datum. Add additional weight of 100 gram to 500 gram as shown in the blank result table. Each time you add weight, record the scale reading from the ruler. Find the difference between the scale reading and zero datum to find the extension for each load. Use a blank chart to plot the load Newton against extension meter. For the experimental procedure 2, energy in a spring, in the second experiment, we investigated the energy stored in a spring. First, we assembled the plummet arm on the side of the work panel, ensuring at the bottom of the wake hanger was between 10 and 30 mm above the dash. Next, we carefully lifted the wake hanger until its hook was just clear of the spring loop. We then measured the distance from the bottom of the wake hanger to the dash and recorded this value as drop height. After that, we attached 2 additional 10 grams masses to the wake hanger, giving a total load of 30 grams. The wake hanger was then raised back to the recorded drop height and released. We gradually adjusted the mass until the bottom of the wake hanger just touched the dash when released. This process was repeated several times to ensure a correct result. Once the correct mass was determined, both the drop height and the mass were recorded. The plummet arm was then moved 20 mm higher, and the experiment was repeated for at least 3 additional drop height. Through the experiment, we ensured that the spring did not extend beyond the limit established in the first procedure. Finally, the gravitational potential energy for each trial was calculated using the equation P equals mgh, where m is the mass, g is the acceleration due to gravity, and h is the drop height. The area under the load extension graph obtained from the first experiment was also calculated and recorded in table 4.2.